Hi, good morning, everybody. Morning, all you cool cats and kittens. As you can see, the setup has changed a little bit. My concern was that I was going to be there one morning and they were going to have everything shut down. So I've kind of set up shop here at home. Let me adjust that a little bit. And so I'm a little bit limited with board space, so we'll do what we can here. It seemed to work out okay yesterday with my 126 class. So we'll see how it goes today. One thing is that normally I have all the stuff written down on the board and leave that there for the duration. Because of the limited board space, we'll kind of have to break it up. And so today we're covering 8.1 and 8.2. For 8.1, this is our introduction to the polar coordinate system. And rectangular coordinate system is your X and Y values. Polar coordinates, we're now using R and theta. And the key with this is that the point's going to be listed R theta, but we move in the direction of theta first and then move our units out. If R is negative, we're going to move opposite of the theta that we just moved. So any questions on that before? Because I know this section here, 8.1 is one of the more confusing one for people. So any questions on just the basic concept of how we move to certain points? And I did get the problems you guys listed on the discussion thread, so I will go through those. But if there's any questions you guys have on this, just let me know. And don't forget, keep reminding you guys here the first few times we're doing this. If you do have a question, just hit exclamation point a couple times and hit enter. That way it'll be an indication to me, all right, hold on, I have a question. I got to type it out here. So. All right, so no questions, I guess. And then is the board okay? Lighting's all right with you guys? If I turn on the light, it seems to put a glare, but if I need to, I can turn it on. So is the board all right with you guys? Sound is okay? Everybody's still sleeping. All right, so then the other part of 8.1 are these relationships between X, Y, R, and theta. And so X is our cosine of theta, Y is R times sine of theta. Our radius squared, looks good, okay, thanks. R squared is X squared plus Y squared, and then tangent of theta is Y over X. So, if there's no questions on any of that, we'll start getting into some problems here. And then for 8.2, so we'll do the problems from 8.1, and then for 8.2, I'll address those. I will say, so normally I would put the stuff for 8.2 up on the board. I still might, but, and I should have mentioned this last class before you got to 8.2. On the files section of Canvas, there's a link for polar graph shortcuts. And so it makes doing these polar graphing problems super easy because it tells you what direction is it facing, what type of figure is it, how many units do we go out, how many units to the side, et cetera, et cetera. So it kind of takes all the guesswork out of it. You just plug the numbers in and it essentially draws the picture for you. All right, so first off, 8.1, number 1. This is always a problem, always an issue. So it's a little bit easier than it makes it seem to be once you kind of get rolling with this stuff. So I need to convert this to rectangular coordinates, meaning that my final answer can only have an R, a theta, or some numbers. So if I want to convert this, any ideas what's the first thing that I can do to simplify this problem? Any ideas, you guys? What can I do? So if I have 7x equals 7y, not going to square it. I can do that, Kyla. All right, so let's do that. We can do that first. So using our substitutions that I had there, x is what? X, so we have 7 times our cosine of theta equals 7 times r sine of theta. Yep. All right, so now what can I do to simplify this? There we go. So Rhea, exactly right. So we can divide both sides by 7. And actually, I can divide both sides by what? Even now that we made that substitution, I can divide by 7r. So if I divide both sides by 7r, this guy becomes what? Cosine of theta is equal to sine of theta. So now I'm going to divide both sides by cosine. So on the left side, cosine divided by cosine is equal to 1. And on the right, sine of theta over cosine of theta is what? Is equal to what? What substitution can I make here? Exactly, Dominic. Yep, tangent of theta. So tangent of theta is equal to 1. So we're pretty close here. Yep, good. So we want our answer to only have r's or thetas or numbers. So the question I have for you guys then is where on the unit circle is tangent of theta equal to 1? When theta is equal to what? Exactly, pi over 4. And this is it. This is your final answer. You're just going to enter in theta equals pi over 4. That's what would go into the box. And so let's think about this problem for a second. Whether I'm dealing with rectangular coordinate system or the polar coordinate system, essentially it's telling me it's the same graph. So 7x equals 7y on a graph, what does that look like? Well, it's the 45-degree line, right? Any equation, if I get rid of the 7s, so x equals y or y equals x, that graph on the rectangular coordinate plane is the 45-degree line. What is theta equals pi over 4? That's the 45-degree line. So these answers, these two equations represent the same thing. It's just one is in rectangular coordinates, the other is in polar coordinates. Does that make sense to everybody? Any questions on that? Okay. So that one honestly was one of the more tricky ones because there's all these substitutions and things like that that you're okay. Yep, question. All right, so hold on for a second. Oh, okay. Yep, just remember it. You can ask it after class. That's fine. All right, so the next problem that was asked about was number 5. So this wanted to convert the polar equation, and you're given negative square root of 6, negative square root of 2. So to convert from rectangular, which is what we have, to polar, we're going to use the two equations. First of all, r squared is x squared plus y squared. This is our value for x. This is the value for y. So therefore, to figure out r, we just plug those in. So r squared is negative root 6 squared plus negative root 2 squared. So negative root 6 squared is just positive 6. negative root 2 squared is just 2. So this means r squared is equal to 8. So r is equal to the square root of 8. Questions on that? All right, second, we need our value for theta because we want to put this in our coordinates of r and theta. So we already figured out r is square root of 8. And so now we have tangent of theta is equal to y over x. So negative square root of 2 over negative square root of 6. So this is what? Negative divided by negative is positive. And using our radical rules, we can combine this, 2 over 6. Simplify this, divide them both by 2, we get 1 over 3. And now break them apart again. So again, this is using our radical rules. So we get 1 over square root of 3. Do we rationalize? You don't have to. You can just leave it as square root of 8. That's okay. You have simplified, I'm assuming. This one we will rationalize, though, and this gives us root 3 over 3. So why did I rationalize it? To give me something that I'm used to seeing. So now, after all of this, it says tangent of theta is equal to square root of 3 over 3. So where on the unit circle is tangent of theta? Well, it's theta. Where on the unit circle is tangent of theta equal to square root of 3 over 3? And we actually have 2 locations. So pi over 6 is 1. And 7 pi over 6, yes. So I have 2 options. So again, it's pi over 6, 7 pi over 6. So which one do I choose? Doesn't matter. Can I just put any one in that I want? So let's think about what I'm doing here. I'm converting this point to polar coordinates. It has to plot to the same location as what I started with. Well, the point that I was given, what quadrant is this point in? Negative root 6. Yep, there we go, Rhea. Perfect. So this guy is in quadrant 3. So I need to choose my value of theta that puts me in quadrant 3, which would be 7 pi over 6. That would be your final answer for this one. Square root of 8, 7 pi over 6. That makes sense. Any questions on that? So again, with these problems where we have to go back, where did we start? Our answer has to put us in that same spot at the end. Okay, good. See, it was worthwhile getting up early today. All right. Let's see here. All right, number 6. So again, we're converting to polar. So we have y equals 6x squared. And we want to convert this to a polar equation. So we, again, just like the first problem, we want to try to get this thing using our substitutions where we end up with an r, a theta, or numbers. Now, I'm going to post a little thing here. So obviously, there's no way that I can take attendance, but attendance is still a component of the class. I want you guys at least logging in the morning here, or if not, watching the videos later if there's problems that you have. So this problem today is the attendance problem. What does that mean? In your ticket out the door notebooks for today, 4-2, I want you to have this problem as the first problem. So I have 2 ticket out the door problems we'll do at the end of today. But the first problem you should have for 4-2 is this one. If you've already done it, perfect. Just copy it over from your notes. That's fine. If not, if you want to do this problem in your ticket out the door notebook, then it's there. That's fine. So at the end of the semester, when I collect your guys' ticket out the door notebooks, on each day, I will look for this attendance question. And if it's there, you get credit for quote unquote attendance grade. If it's not there, it will deduct from your attendance grade. So please be sure to put this problem, number 6 from 8.1, in your ticket out the door notebook on April 2nd. That makes sense? Any questions on that? And then go ahead and try this one. So I'll give you guys a few minutes here to work on this one. If you guys are working this one and you finish, just type done so that I know that you guys are done working it. If you're stuck, you can either try to ask a question through the comment section there or just type done as well. I know that you've kind of gone as far as you can, and then we'll work this one together. Okay. Yep. Okay, Andy, go ahead and ask your question. Okay, done. Shane, good. You know, so ideally, a polar equation is always going to have the form R equals something. Now, they tricked us a little bit because the very first question that we did here, question number 1, was theta equals pi over 4. So that kind of throws everybody off. But generally speaking, when we're doing polar equations, it's going to have the form R equals some value. So ultimately, that should be what you're trying to get to, is R equals something. Again, that first problem was a little bit tricky and kind of throws us off from that methodology. But generally speaking, that's what you're trying to do. Try to get it to be R equals something. Is everybody else still working this, or are you guys done? I know only 3. There's 17 people logged on. 3 of you told me you're done. So I don't, if you guys are still working it, I want to make sure to give you time. And did that answer your question, Andy? Okay. Okay. All right, so it looks like you guys are wrapping this up, so let me go ahead and work this. So I was going to be using these substitutions, those first 4. Yeah, that's fine, Stephen. Welcome. All right, so for y, we have what? That's r sine of theta. And then on this side, 6 and x is r cosine theta. Be careful because the whole thing is squared. So if I bring in that squared, I get what? I get r sine of theta on the left, 6, and I bring this to both pieces. So r squared cosine squared. So if I want to get r by itself, I can divide both sides by r here, and that will leave me with just one of them on the right. I could have brought the r squared over, but now I have 1 over r, which means I'm going to have to flip everything at the end. So this way I just have r, so I have 6r cosine squared theta on the right and sine theta on the left. So to get r by itself, what am I going to do? I'm going to divide by 6 cosine squared of theta. So over here, everything cancels out except for the r. And on the left, I'm going to do that little trick we did when we were doing simplify and proof problems, which is to say I'm going to break this thing apart. So this is like 1 over 6 times sine over cosine times 1 over cosine. Does that make sense to everybody? If you guys remember back in, what was that, 7-1? Yeah, 7-1, where we broke it apart. So this becomes what? 1 over 6. So r equals, if I bring the r to the left side, r equals 1/6. Sine over cosine is tangent. So tangent theta. And 1 over cosine is secant. So secant theta. Okay, good, perfect. So that would be your answer. 1/6 tangent theta secant theta. Any questions on that one? All right. And so again, please make sure you have that one in your ticket out the door notebook. All right, next one, number 7. So this is one of the trickier ones. We want to convert the rectangle, meaning, okay, so go ahead and type your question, Shane. So for 7, we have 16 over 1 plus 4 sine of theta. All right, now we'll hold up for the question here. So we are just simplifying down like the past problems. Yeah, more or less. So we're trying to get rid of, so it depends. Like for this problem, we have r and theta. We want to convert it to x's and y's and numbers. The last problem, we had x, y's, and numbers, and we wanted to change it to r's and thetas. But then, yeah, once we make those substitutions, simplify it down as far as possible. Okay, so this guy here. So I will tell you, this used to be an exam problem. I honestly have no idea how I could write this problem as an exam problem on the Canvas platform. So it probably won't be anymore. Well, I guess I could just have what's your final answer, but with the formatting and stuff, I don't want to run that risk for you guys. But it's a good problem. It's testing kind of what you know what you're doing. So the first thing we're going to do for this problem is multiply both sides by the denominator. So we want to get rid of the denominator here on the right. So if I multiply the right by the denominator, I have to multiply the left by the denominator. So on the right side, I'm just left with 16. On this side, I want to distribute the r. So I have r plus 4 times r sine of theta. So I can make a substitution here. Again, my ultimate goal is to get x's and y's in this problem. So I have an r sine of theta. What is r sine of theta equal to? What is r sine of theta? Yeah, exactly, y. So this whole piece just converts to y. So we get r plus 4y equals 16. Now, the only thing I have left here, as far as r's and thetas that I need to substitute, is this r. If we look at my different possibilities for substitution, I don't have an r. I have what? I have an r squared. So if I can get this to be an r squared, then I can make my last substitution. But here's the issue that I have. If I square both sides at this point, I'm going to end up with a middle term of 8ry. And that just makes the thing messier. So the trick with this problem is I need to first subtract 4y. So I get r equals 16 minus 4y. Does that make sense to everybody? If I just square both sides at this point, this guy, r plus 4y squared, is r squared plus 8ry plus 16y squared. And now this guy gives me an issue. So I don't want to do that. I have to move the 4y first. Now go ahead and square both sides. So we get r squared on the left. And be careful over here. So you're just getting r by itself. Yes, yeah, we want to get r by itself. And now that r is by itself, now we can go ahead and square both sides. So on the left, I get r squared. And over here, don't forget from your binomial theorem, we're going to end up with what? 3 terms. This is like 16 minus 4y times 16 minus 4y. So we get 256 minus 128y plus 16y squared. And now I can make my last substitution. This guy is really what? X squared plus y squared. And technically, you're done here. Because the whole point was to convert this thing to x's and y's and numbers, and that's what you've done. If you want to make it look clean and bring everything over to the left side, that's fine. But otherwise, if you enter that into WebAssign, it should take it as an answer. So any questions on that one? Okay. So the next one is number 10. So you are given the point 4 pi over 2. And you want to list 2 other polar coordinates. One with r is negative, one with r is positive. So let's first of all figure out where is this point on the polar graph. So we always move the direction of theta first, so pi over 2. So that puts us up here on the y-axis, and then it's 4 units out. 1, 2, 3, 4. So if I had my circles drawn here, we get that guy there. So let's do the negative r first. So for r is less than 0. So if r is less than 0, that means what? So let's say, for example, if I have a point negative 2 pi over 4. So in this case, r is negative. So how do I plot this point? Well, the first thing I do is move to pi over 4, which is this 45-degree line. But the negative means what? It means I don't move in the direction of pi over 4. I move the opposite way. So if I have my circles here, I'm moving 2 units down into quadrant 3, not into quadrant 1. So does that make sense to everybody, what the negative r means to us? And if not, hit the exclamation point so I know to explain it again or try to re-explain it. Okay, so for this one, if my r is negative, it's going to be what? Negative 4. But what's my value of theta such that when I go negative 4, it puts me up here? Well, negative 4 means that my theta has to put me down here at the bottom of the graph. So what is this point? Well, this is 3 pi over 2, and then negative 4 tells me to go the other way on the graph. So we get that value there. And let me just check the problem again here. Yeah, okay. All right. So now for r is greater than 0, so that means r is going to be positive again, so positive 4. So it means I have to get to this point with a theta that just ends up there. So I could do what? I could do either negative 3 pi over 2, that will put me up here, or I could do what? Pi over 2 plus 2 pi to come all the way around the circle. So pi over 2 plus 2 pi, that'll get me another time around the circle. So this is pi over 2 plus 4 pi over 2, which is 5 pi over 2. So those would be your two answers. If r is negative, it means we have to be on the opposite side of the graph. If r is positive, it means my theta needs to put me at that location. That makes sense? Questions on that? All right. All right, and the last one you guys had a question about was number 14. So we want to convert to a rectangle, polar. Check real quick. To polar, yeah, okay, that makes sense. All right, so we have x squared plus y squared is equal to 36. So if I want to convert this to polar, it means all I want left at the end is either an r, a theta, or numbers. So can I make any substitution here? Or do I have to do some work first? So what are we going to do on this problem? Exactly. So just as Chase says, this is one of our substitutions, right? X squared plus y squared is r squared. So this equation is r squared equals 36. We want just r by itself. So how do I get r by itself? Square root both sides. Now, typically when we take the square root, we have what? Plus or minus. However, this is talking about the radius, and so we're just going to go with the positive value. So this becomes simply r is equal to 6. Then, any questions on that one? This is the so we actually square root both. So we didn't have to do anything at the start other than make this substitution. X squared plus y squared is r squared. And that was from that first list of 4 that I gave you guys. So this guy is r squared, but we want r by itself. So I'm going to take the square root of both sides, and that gives me just r is equal to 6. We didn't need to square this one, just square root. So any other questions on that? So you guys didn't say you had any questions on 8.2. I know it's a lot of, okay, good. It's basically just a lot of multiple choice. They give you an equation. Oh, number 5, I will be deleting number 5. It's like an r squared something, and it gives you like an infinity symbol. We're not going through that. The only thing you guys are responsible for is the cardioid, the lemicon, and the rows. Any other questions, 8.1 or 8.2? All right, well then let me give you your ticket out the door problems. And then I'll bring Cash in so you guys can meet him today. So ticket out the door number 1. And so you may want to use this polar graph shortcuts that was on Canvas to do these. So sketch r equals 2 minus 2 cosine of theta. And number 2, sketch r equals 2 minus 3 sine of theta. Go ahead and try those. And then after a few minutes, I'll put the answers on the board for you guys. Obviously, there's no door that you're having to leave. Probably most of you guys are still in bed, which makes me jealous. But that's fine. So, Cash, come here, bud. Come on in. You want to meet the class today? So here's Cash. Looks like I goofed something up with the connection there. So, anyways, you want to see her? Come here. So here's Cash, hanging out, meeting everybody. Okay, back to bed. Go ahead. Go. Come on. Good boy. All right, so again, have you guys sketched these? Yeah, he's a good boy. My old man with the frosted face. Next few days, or next classes, I'll let you guys meet Ginger and Bambi too. Ginger's pretty camera shy, so we'll be, I'm Bambi shy. So I'll probably have to go get her, but Cash is more accommodating. So if you guys get these done, go ahead and just put done, and then I'll draw them out for you. If you don't have them, that's fine. Again, I'm not really concerned so much about, oh, I gave you the answer. I want you to have the answer. Okay, yeah, go ahead, Stephen. I want you guys to have the answer, but ideally, as you know by now, these are, review type problems for the exam. So that's more my bigger concern, is that you understand how to do these, so that if there's a question like this on an exam, you're able to do it. So probably what I'll have to do for the exam for this one, what's the difference between the question you marked earlier? Okay, so the one earlier was your attendance question. So you need that question in the ticket out the door notebook. That counts towards your attendance grade, because obviously there's no attendance that I'm going to be taking in class. And it varies. Like right now, it says there's 19 people viewing. So some students may just go back and watch this video later, which is fine. You're still kind of doing what you're supposed to do, hopefully getting the questions answered that you have. So the earlier question, the number 6, I think it was, that one in your ticket out the door notebook counts as your attendance grade for being here today and putting up with me and watching these videos. These ones are your ticket out the door. Will the ticket out the... Yes. So the ones where I work the problems, I'm assuming, is what you mean. So yeah, at the end of the semester, I'll film the ticket out the door videos again, and those will be posted to YouTube, and those will stay up. They'll probably stay up forever, because I'll probably just use the same questions in future semesters. So yeah, so those will stay up on YouTube. Anyways, as I was saying, I have to figure out how I can ask this type of question on the exam. How do we turn these in again? So your ticket out the door notebooks, you'll turn in at the end of the semester. So probably after exam 3, we have like 2 weeks, I think. Yeah, I think 2 weeks before the final. So I'll just have you guys waiting. I'll just have you guys turn them in. So either stop by campus, drop them off. I know that they're saying April 30th is the day that we can all go back to life as normal. We'll see. But at least as of now, the plan is I'll have you guys drop them off. If we still aren't allowed to be on campus or any of that, I'll probably just have to have you guys like scan them in or something, or I'll figure out some other plan. But unfortunately, it's kind of figuring it out on the fly here. But at least that's a plan for now. I can't see question 2. Okay, is it because of the glare? So question 2 is R equals 2 minus 3 sine of theta. So actually here, I'll just type it on here. I can do that. So number 1, R equals 2 minus 2 cosine theta. Yep, and there you go. And so Stephen has number 2. Number 2 is R equals 2 minus 3 sine of theta. You guys have this one done? The video is like, oh. I don't know, is everybody else having that problem? Video's fading in and out? Oh, okay. Yeah, it seems when I moved the screen before, then it told me something about the internet connection. So it's weird. Make sure this is plugged in. Oh yeah, looks like. Yeah, it looks like. Okay, now it looks like I'm back on cable. Yeah, for some reason it switched over to Wi-Fi, so maybe my Ethernet cable was loose or something. So anyways, I'll leave the door open. That's what I was saying a few moments ago. Yeah, okay, I gotcha. Okay. So let me give you guys the answers here then. So that way, if for some reason the internet gets funky, at least you have the answers. So this one, the way we would process these problems is, first of all, these numbers are the same. Therefore, this is a cardioid. Cosine tells me they're pointing left or right. And because of this minus sign, that tells me it's a cardioid pointing to the left. Now, to figure out the points here, the tip of the heart is I just add these two numbers, 2 plus 2. So 4. The sides, so this is like my A, that's my B. So the sides are just whatever the value of A is. So 2. And then I always have the origin. So I have a point at the origin. I have my polar graph here. The tip is at the left side, 4 units out. And the sides are 2 units from the origin. And then try to make it a nice big fat heart. Don't try to put any points. So that's what you should get. Actually, let me change the color here so you can see it. So you should get that, a heart pointing over to the left. And then for this guy, so the numbers are different, therefore it means it's a lemicon, which is a heart with a loop in the middle. Sign tells me up or down. And because it's a negative sign here, it means that it's a cardioid pointing down. Now the tip, add these two numbers. Don't worry about the plus or minus anymore. That was only telling me which direction. So now I'm just worried about 2 plus 3. 2 plus 3. So that's 5, meaning the tip is 5 units down. The sides, just like with the cardioid, is the first number. So 2. So 2 units to the left, 2 units to the right. I always have the origin. Don't forget about that. And then lastly is the loop. So the loop is just a bigger number minus the small. 3 minus 2, which is 1. And again, it's going downward because the loop has to be inside. So for this one, your picture should look something like that. So a heart pointing down with a little loop, 1 unit long. So that's about it. That's what we have for today. I will probably be there is an assessment due on Sunday over 8.1 and 8.2. So just make sure you do that. Don't forget about that. I'll probably post on the announcements just as a reminder. I'm having trouble seeing. All right, so we'll try to wrap this up before it gets too funky for you guys. So anyways, I'll put a thread on there, kind of getting your guys' feedback, how this worked. Maybe we need to switch to like WebEx or something like that. At least that way you guys can talk to me as well, rather than have to type everything. So, all right, yeah, it looks like we're having some issues here. So hopefully this doesn't become an issue. But anyways, so if you guys have questions, can you take a picture of the board and upload it, please? Okay. All right, yeah, so I'll do that. I'll take a picture. Okay, no problem. So I'll take a picture of this. I'll upload it to Canvas so that you guys have it. Otherwise, I guess I'll say bye to you guys. Have a good weekend. Stay safe, and we'll talk to you guys on Tuesday.